Hi students, and welcome to our algebra lesson today where we're going to be dividing polynomials by monomial. We'll start with our do now where we have a prompt about positive self-talk. We can all use a little bit of that. And our objective today will be to divide the polynomials by a monomial. And our essential question is, how can I divide a polynomial by monomial? And how does the quotient rule work with polynomial numerators? So let's talk about that as we get to it. Our assignment today will be to complete our do now. We have 2 pages today, an exit ticket. If you're a distance learner, please submit a photo of your page on Teams. And that's even if you're an in-person learner part of the weeks, those days that you're home, I need to see your work. If you're an in-person learner, I will walk around and I will see what you're doing. For tonight, let's do homework 4, dividing polynomials by monomials. Remember to stay current with your homework so that you're ready for that quiz on the 9th. We have a nifty exit ticket here. We'll get back to that in a minute. Here's our do now. So, we've all had something like this happen. We're going to reframe our response to these things in a more positive way. So here we go. Ugh, another bad test grade. And you might be tempted to say, what's the matter with me? Why can't I learn this? I'll never have a good career. Guys, we need to reframe that language and allow our brains to hear something positive. Okay, I need to get extra help. Oh, I need to talk to the teacher. Maybe I can get my mom or my older sister or brother to quiz me the night before the test. Maybe I can, maybe I need to just spend more time with this. Maybe I can make some flashcards. I'm going to try to make flashcards. This was a bad day. I'm going to make flashcards. Maybe I can get a takeover, and I'm just going to do it right. So those are different ways, and you have many, many more, that you can reframe that negative talk, right, yuck, into a more positive way so that you can grow and be better and better every day. That's our goal. So let's get into our dividing a polynomial by a monomial. There's a reason we do polynomials and factoring right after we do exponents and exponential equations. And it's not just because of that COVID math that we always talk about, those exponents. But we use these exponent rules to factor and to multiply, divide, and perform operations on our polynomials. So we'll start out with a reminder of the quotient rule, which is if you have x over a and you divide it by x over b, your solution will be x a minus b. Now, if your b term is larger than your a term, do not be tempted to switch them around. It's got to be the a term first, and the b term is subtracted from the a term. Do not deviate from that. If you have a negative exponent, put it in the denominator to make it positive. You know that. So, dividing a polynomial by a monomial. I want you to think of it like this. We have 8n squared minus 36n divided by 4n. So we're going to take 8n squared, put it over 4n, okay? And then we're going to have 36n. We're going to put subtraction in the middle and divide it separately by 4n. And what happens? Well, 8 divided by 4 is 2, and n to the second power divided by n to the first power is simply n, which is n to the first power. And 36 divided by 4 is 9, and n to the first power minus n to the first power is n to the 0 power, which equals 1, and we don't need to write that. So our final answer is 2n minus 1. So what did I do? To divide a polynomial by a monomial, we divide each term in the numerator by the term in the denominator. And for exponents, remember that quotient rule. So, remember, terms are separated by addition and subtraction. We've got negative 14 x to the 12th, y to the 5th, plus 7 x squared, y squared. And we're going to divide each term by that 7x squared y squared. Well, the right side is just going to cancel itself out, right? On the left side, we have negative 14 divided by 7, which is negative 2. X to the 12th divided by x to the second power is x to the 10th power. Y to the 5th divided by y to the second power is y to the third power. Now, this 7x squared y squared divided by 7x squared y squared. Anything over itself equals 1. So we will account for that by putting a 1 in our answer. So our final answer, negative 2x to the 10th power, y to the third power, plus 1. So let's try these out. So 6x divided by 3 plus 9 divided by 3. So this would be 6 divided by 3, 2x plus 3. Now, 10v squared divided by 5 is 2v squared. 5v divided by 5 is simply v. And 15 divided by 5 is 3, and it's going to be a negative 3. So 2v squared plus v minus 3. All right, we've got a trinomial in the numerator with a in the denominator. So that would be 8a to the third divided by a is 8a to the second power. Negative 2a to the second power divided by a is negative 2 minus 1. Don't forget your invisible 1 is 2a. And 5a divided by a, and they're both positive, is going to be 5, because the a to the first over a to the first equals a to the 0 power, which equals 1, and it would be like multiplying 5 times 1, which is 5. So let's do number 4. So 40x squared divided by 8x is 5x. 8x divided by 8x is 1, and that's subtraction, so that's our final answer. So try 5 through 8, and let's see how you do, and then come back and check your answers. Okay, let's see how you did. So 18c to the third divided by 3c is 6c to the second power. Negative 21 divided by 3 is negative 7. C squared minus c is c. And 3c divided by c3 is a positive 1. Number 6. 6a squared b divided by negative 2ab. So we don't have a square on the b. It's just b to the first power, b to the first power, a to the first power in the denominator. So 6 divided by negative 2 is negative 3. A squared divided by a is a to the first power, which will be an invisible 1. B to the first divided by b to the first, that becomes like we're multiplying by 1, and we can eliminate that. So negative 12 divided by negative 2 is a positive 6. A divided by a, same thing. Those will just equal 1, like multiplying by 1, so it goes away. B squared divided by b to the first power is b, so negative 3a plus 6b is our answer. Number 7. We're dividing negative 20x squared minus 5x by 5x. So we're going to have a minus 1 at the end. So negative 20 divided by 5 is negative 4, and then we'll have 1x. And negative 5 divided by 5 is 1, and the x minus x. So no matter how you think about it, it's just negative 5x over 5x is going to equal negative 1. Okay, number 8. So maybe I write this out a little bit for you. 14x to the 6th power y to the 3rd, and in the denominator, negative 7x to the 4th power y minus 49x to the 5th power y to the 9th, again, still divided by negative 7x to the 4th power y. So we'll work on the left side first, which will give us negative 2x squared y squared, because 3 minus 1 is 2, minus 49 divided by 7. I want you to think of this as a negative 49 divided by negative 7, so that's plus 7x. 5 minus 4 is 1, y, 9 minus 1 is 8. Now, we do not have like terms. X squared, x, y to the 8th. We cannot combine like terms. We cannot add them together, so that's a final answer. Let's go with number 9. So negative 25x4 y to the 3rd plus 30x squared y to the 5th divided by negative 5x squared y. So negative 25 divided by negative 5 is a positive 5. X 4 minus 2 is 2. Y 3 minus 1 is 2. Positive 30 divided by negative 5 is negative 6. The x squares will cancel, and y to the 5th divided by y is y to the 4th. And there's our final answer. Number 10, 20a to the 7th, b to the 3rd, c to the 2nd power, and we're going to divide that by 5abc. 20 divided by 5 is 4, a to the 7th divided by a is a to the 6th. B to the 3rd divided by b is b squared, and c squared divided by c is c. Now, look what we've got. Minus 5ab divided by abc divided by 5abc. That's negative 1. And there's your final answer. So let's move on to the next group. And I'd like you to try these next 6 on your own and then come back and let's see how you did. I hope you do that. Okay, so let's see how you did. Number 11, 16x to the 6th divided by 4x squared is 4x to the 4th. And negative 12 divided by 4 is negative 3. X to the 4th divided by x squared is x squared. And then we have this 4x squared divided by 4x squared. That's our plus 1. So 12c to the 5th, d to the 4th divided by 3, c to the 2nd, d to the 3rd. 12 divided by 3 is 4. C to the 5th divided by c to the 2nd is c to the 3rd. D to the 4th divided by d to the 3rd is d to the 1st, and we can leave that exponent off because it becomes invisible. Now on the right side, 18 divided by 3 is a positive 6. They're both positive. C4 divided by C2 is C squared, and D3 divided by D3 just becomes multiplying by 1, and we eliminate that. Number 13. Negative 24x to the 7th power divided by 3x to the 5th power is negative 8x squared. Now, 9 divided by 3, that's a positive 3. But what we have here, we're going to have to account for a negative exponent here in a minute. So this would be 3 minus 5, which is 3x to the negative 2, and we're going to rewrite that. So when we have 3x to the negative 2 power, we can put 3 in the numerator and x to the 2nd power in the denominator. And you can go ahead and do that right now. So you can just make a fraction in the middle there, 3 on the numerator, x squared in the denominator. And then in the next term, we have 15. So negative 15 divided by 3, negative 5. X, 1 minus 5 is negative 4, but we're also going to rewrite that one, which would be 5 in the numerator, x to the 4th in the denominator. So leave the negative sign in, we need that. And you can write this like this, and you are finished. And we have something similar with number 14. So we have 15x to the 5th divided by 5x to the 4th. So that would be 3x, because 5 minus 4 is 1. Then we have negative 25x to the 3rd divided by 5x to the 4th. So that would be negative 5x to the negative 1. We'll come back and fix that in a minute. And then we have 5x squared divided by 5x to the 4th. That would be a positive 1x raised to the negative 2 power. So we can rewrite that 3x minus, so here we put our fraction bar, 5 in the numerator and x in the denominator. We can make the 1 invisible now because x to the 1st power, we don't have to show that 1. Plus, and we put the next term also has to go in the denominator, and we don't have a coefficient, so we can put a 1 in the numerator. And number 15, it's just a lot of x, y's, and z's. It's just two terms. 28 divided by 4 is 7. X to the 5th divided by x to the 7th is x to the 3rd. Y to the 4th divided by y to the 2nd is y to the 2nd. Z to the 3rd divided by z to the 2nd is z to the 1st, or simply z. 8 divided by 4 is 2. X to the 4th divided by x to the 2nd is x squared. Y to the 3rd divided by y squared is simply y, and the z squares will go away. Z squared over z squared is like multiplying by 1. So 7x to the 3rd, y to the 2nd power z, plus 2x squared y is our final answer. And number 16, 30 divided by 3 is 10. R, 5 minus 2 is 3. S, 9 minus 2 is 7. Minus 12 divided by 3, 4. R, 4 divided by r to the 2nd is r to the 2nd. S, 8 minus 2 is 6. And then we have a positive 3 divided by 3. That will be an invisible 1. So it's positive. And that'll be R. 3 minus 2 is 1. S. 7 minus 2 is 5. And that is a final answer. We cannot reduce that any further. So now we've got some challenges where we're going to put it all together. And the only challenge is really just organizing your work and working slow and carefully. So we'll start with the left side here. So 15 divided by 3 is 5. X squared divided by x is x. Plus 6 divided by 3 is 2. Excuse me. Okay, and that will be multiplied by 2x minus 1. And so we're going to have to FOIL. So first outer, inner, last. So 5 times 2 is 10x squared. Outer, 5x times negative 1 is negative 5x. Inner, 2 times 2 is 4x. And last, 2 times negative 1 is negative 2. We can combine the negative 5, the positive 4 for negative 1. 10x squared minus x minus 2. Oh boy. Take a look at number 18, slow and careful. First, we need to distribute this term through the 1, 2, 3 terms here. And we're going to be using the product rule because we're multiplying. We're not raising to a power. This is distributing and multiplying. So 2 times 7, 14, R, 3 plus 7, 10, S to the 8th. That's the first term. Now, 2 times negative 5 is negative 10. R, 3 plus 3 is 6. S, 4 plus 8 is 12. Okay, oh, 2 terms there. I misunderstood that. I thought there was another subtraction sign there. Okay, so it's easier than I thought. Now, all you're doing when you have a subtraction outside of a quantity like this, it simply changes the signs. That's all it does to everything inside. So this would now be a negative 2r to the 10th s to the 8th, and the negative times a negative makes that a positive 6r to the 6th s to the 12th. And then all of that is divided by 4r to the 2nd s to the 4th. So let's give ourselves a little more room here. I think I should change the color a little bit. So 14 R10 s to the 8th. We can do some combining like terms. Let's do that first. I'm looking at 14 R10 s to the 8th and negative 2 R10 s to the 8th. So 14 minus 2 is 12 R10 s to the 8th. So I've combined this term and this term. Now what else do we have? Negative 10 r to the 6th s to the 12th plus 6 r6 10 s to the 12th. That's a negative 4 r6 s to the 12th. Now we divide that by 4 r2 s4. So 12 divided by 4 is 3, and our r would be 10 minus 10 minus 2, which is 8. And S would be 8 minus 4, which would be 4. And then we have minus, so it's going to be negative. 4r divided by 4 is just negative 1, so that is eliminated. R, 6 minus 2 leaves 4, and S, 12 minus 4 leaves 8. And there's our final answer, 3r to the 8th, s to the 4th, minus r to the 4th, s to the 8th. We can't simplify it any further. So number 19, we've got the m's and the n's again. So we're going to multiply the numerator together first. We're going to do this work first before we divide. So, and we'll probably have to do some combining of like terms as well. So m squared, n squared, we use FOIL, times m squared, n squared is going to equal m to the 4th, n to the 4th. And now we'll do our outer. M squared, n squared times mn. So that would be a positive m to the 3rd, n to the 3rd. Now we'll do the inner terms. Negative mn times m squared, n squared, which would be negative m to the 3rd, n to the 3rd. And then last, negative mn times mn, so negative times the positive, you add the exponents of 1, which would be negative m squared n squared. So what I see here is we have a positive m3n3 and a negative m3n3, so those will be eliminated. So that makes our work a little bit easier. So let's rewrite. We have m to the, all right, and I'm just going to put the divisor in there. Okay, rewrite m to the 4th, n to the 4th, minus m to the 2nd, n to the 2nd, divided by mn. So m to the fourth n to the fourth divided by mn is simply m to the third n to the third, and then minus m squared n squared divided by mn is mn. And that's the end, that one. And then number 20. Let's multiply the numerator before we divide by the denominator. We'll see if we can combine like terms. I don't think we're going to be able to with this. So we'll start here. First outer, inner, last. 4 times 5 is 20, and that would be k to the fourth. Outer, 4 times negative 3 is negative 12, and that's k squared. Inner, 2 times 5 is 10, and that would be k to the third. And last, 2 times negative 3 is negative 6k. And all of that is divided by 6k. And I don't see any opportunities for simplifying or combining like terms. So let's just get started. 24 or 2, 20, I left out my 0. 20 divided by 20k to the fourth divided by 6k is, all we can do is reduce it. So we'll divide 20 by 2 to get 10 and 6 by 2 to get 3. And that would be k4 minus 1 is 3. Negative 12 divided by 6 is negative 2. K squared divided by k is k. And then 10 divided by 6 will simplify to 5/3 k, which is just dividing everything by 2. 3 minus 1 is k squared. And then negative 6k divided by 6k is negative 1. So the only problem I have with this is it's not exactly in standard form. So I'm going to write it just in the correct order, which is 10 over 3 k to the third. And then I'm going to write the squared term. So that's a positive 5/3 k squared. And then our negative 2k minus 1. And just to rewrite, to put everything over. So that's our final answer. So let's go to our exit ticket and see if we can kind of do that challenge problem. You ready to try that? So let's see. And actually, this challenge problem is one of your homework problems. So 45 45p5q4 divided by 15p2q3. So I'll write over here. 45 divided by 15 is 3. So it would be p3q minus 60 divided by 15 is 4. That'd be 4pq minus, this would be pq to the negative 1. We don't want to forget that. 2 minus 3 is negative 1. And then negative 15p2q3 divided by 15p2q3 is same as minus 1. So we need to get rid of the negative exponents. We have to rewrite that. So that would be 3p to the third power q minus. So we can put 4p in the numerator and q with an exponent of 1, which then becomes an invisible exponent in the denominator, minus 1, and that's your final answer for your exit ticket. So good job learning these. Remember, it takes a lot of practice. I put a homework key in with the work in with this document that you're looking at right now for last night's homework. Try tonight's homework, and tomorrow I'll remember to put a key in there for you for tonight's homework. So keep practicing hard, because as always, if you practice, 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 you'll be great.